Let's now talk about how to find the reduced row echelon form and the rank of a matrix. Let's talk about how to find the rank in Python first. So the command for that, we can still use the NumPy that we have earlier. The command is going to be linalg. Again, this is linear algebra dot matrix underscore and then rank. But this will only give us the rank of a matrix. For example, if I want to find the rank of this guy, then again, I can just go to Python and then let's say my matrix A is going to be numpy.array. And then I'm gonna have two sets of matrix here. And then my first row is gonna be 1, 2, 3, 4. And then my second row is gonna be 5, 6, 7, 8. Okay. And then to find the rank of this matrix, that's going to be numpy.linalg and then dot matrix underscore rank. And then I want to find the rank of the matrix A. So let's try that here. Okay. So the rank is 2. Yeah, so that makes sense. So it agrees with what we have earlier when we do example 1.4. So we actually do this two example earlier in the example 1.4. So this is in example 1.4. Now then, if we want to find the reduced row echelon form, then we actually have to pull out something else. So to find the reduced row echelon form of a matrix, I actually have to call up another package, which is SymPy. This is for symbolic computation. The command for that is going to be matrix and then dot rref. So this is the reduced row echelon form basically. Okay, so let's try that here. To find the reduced row echelon form of this guy, so I'm gonna first have to import SymPy. So I'm just gonna import SymPy as sp. And then I'm just gonna use the same matrix here. If I want to find the reduced row echelon form for this matrix, the command for that is going to be sp sympy and then dot matrix. And then the matrix that we want is gonna be this matrix A. And then dot rref. And then just in parentheses, let's see what we get. Okay, this gives us the reduced row echelon form of the matrix, and this agrees with what we have found earlier in the example 1.4. The 0, 1 here that you see at the end, this is just the location of the leading one. So notice that in Python, the index starts from 0. So what Python sees is that this is this is column 0, column 1, column 2, and column 3. So 0 and 1 here that means in the column 0 and column 1 according to Python. That is a leading one here. So let's try to do the reduced row echelon form in the next example. So my matrix here is going to be 1, 2, 3, and then 4, 5, 6. I'm just going to simply recycle what we have from earlier. And then 7, 8, 9. Okay. Yeah, so once again, this is the same matrix that we see earlier. Now, if I want to do the same thing in Wolfram, so the command for that is going to be just row reduce. You can just type in row reduce and it will actually ask you to put in the matrix. For example, I can just put in the matrix that we have for part A. So it's going to be 1, 2, 3, and then 4, and then 5, 6, 7, and then 8 here. Okay. And it will give me the same row reduce form that we have from earlier. Now, one thing is that the Wolfram is not very picky when it comes to the kind of bracket that we put in. So if we try the brackets that we have from here, so let's try to find the row reduce of the second guy. But let's see. Yeah, so it understands this is the matrix and then it gives me the row reduce form. So now, or we can actually just go ahead and ask Wolfram to row reduce the matrix that we have to begin with. And it will tell me the same answer as well. Okay, so let's move on. For the next one, this is the system of equation that Python cannot solve from me earlier. So Another way that we can work around with this is to actually just find the reduced row echelon form for this matrix. So if I pull up my Python again, I'm just gonna let my matrix in this case, that's going to be, let's see, 1, 1, 3, and then 2, 2, 5. And I'd like to find the row reduced form of this guy. Yeah, so it gives me the row reduced form of this guy. And notice how, because I have a leading one in the last column, so that means there will be no solution to the system of equations. So basically, Python can solve a more complex system of linear equations for you, but you just have to work around and input that as the augmented matrix. For the next one, if I want to find the reduced row echelon form and the rank of the second guy, let me actually first write the answer for the first one. This is going to be 1, 1, 0, and then 0, 0, 1. If I want to find the reduced row echelon form and the rank of this guy, so I'm just gonna pull up my Python so I can see that. So I'm just gonna have 1, 1, and 2, 2 here. Yeah, I get 1, 1, 0, 0. Notice how that makes sense, because if I just subtract 2 times row 1 from row 2, I'm just gonna get simply the first row, and the second row is eliminated. And then I only have one leading one in the first column. Notice again that in Python, the index starts with 0. So my matrix will then be the reduced row echelon form is 1, 1, 0, 0. And now you can just eyeball the rank from the matrix that we have here. So the rank of the first guy is gonna equal to 2, and the rank of the second guy is gonna equal to 1. Now let's look at the last two examples. So once again, this corresponds to a system of equations that Python cannot solve earlier. So if I were to ask it to solve it in this form, so I'm gonna have to type it in as a matrix. So let me just copy and paste what we have here. Let's see, I'm just gonna go copy and paste the matrix that I have from earlier. Okay, there we go. So this is my matrix. Then I'm just gonna simply paste that here, and I'm gonna have to add another column, and that's gonna be 9, and then 0, and then 20. Okay, and let's see what we get here. So here's my reduced row echelon form. Python tell me that the reading row is in the column 0, column 1, and column 3. So let me actually write this down. So the reduced row echelon form for this guy is gonna be 1, 0, 5, 0, 2, and then 0, 1, negative 2, and then 0, and then negative 1, and then 0, 0, 0, 1, and then 3. So I'm gonna have a leading one here, here, and here. So that means my x1, x2, and x4 is going to be the dependent variable, and my x3 is gonna be free. So for the solution, I'm just gonna have x3 equal to itself. I have x1 plus 5x3 equal to 2. So my x1 is gonna be 2 minus 5x3. And then my x2 minus 2x3 is going to be negative 1. So that's going to be negative 1 plus 2x3. And then my x4 itself is just going to equal to 3. Notice how this is actually the same solution that Wolfram gave me earlier. But it's just that, like sometimes the free variable and dependent variable can interchange. So the Wolfram answer that we get earlier treat x1 as the free variable, so x2 and x3 depends on the value of x1. However, if we were to write it in reduced row echelon form, then my x3 is going to be a free variable, and the value of x1 and x2 is now going to depend on x3 instead. And the rank of this matrix, notice how it has 3 reading 1, so the rank is going to be 2. So let me actually move this a little further down. The rank of this guy is going to be 2. Now, if I want to find the rank of this matrix, notice that this is actually the same matrix that we have earlier. I just don't have the last column there. So let me just go ahead and modify what we have this a little bit. So I'm gonna have this thing. Okay. Notice how this is actually just the same matrix that we have from earlier. I just ignore the last column, but everything else kind of stays the same, and the rank is still going to be 3. So I'm just gonna go ahead and copy and paste the same thing that we have from earlier. Okay, so that's the thing that we have, and then I will no longer just not have the last column. Okay. So we actually are gonna come back to some of these examples later. So